Another common case for the integration by parts is called repeated use of integration by parts. Like in this example, we have the product of the e to the negative x and the cosine x as the integrand. Use the liaise to identify the type of these two functions. E to the negative x as an exponential function, cosine x is the trig function. So let u be the cosine x, e to the negative x dx is the dv. As u not the polynomial function, we cannot use the tabular method. So we use the traditional by parts as the formula, the integral of the u dv equals u times v minus integral v du. Let the original problem here represented by the I from integration. So the I, which is in the form of integral of the u dv, so equals the u times v minus integral v du. For this case, since u is the cosine x and the dv is e to the negative x dx, the du or the differential u is negative sine x dx. The v or the antiderivative of e to the negative x dx will be negative e to the negative x. Replace it into the formula of the by parts. U is the cosine x. The v is negative e to the negative x minus the integral, the v, which is negative e to the negative x. Du is cosine, sorry. The du is negative sine x dx. We write it in the better form. We have negative e to the negative x multiplied by cosine x. Three negative signs becomes negative integral e to the negative x sine x dx. As we see, after we apply one round of the by parts formula, it come back to the similar form as the original integration. But this time, if you still use the liaise to identify those two functions, we have the same two categories as e to the x, e to the negative x as the exponential, but the trig function now is the sine x. This time we're gonna let u be sine x and e to the negative x dx is the dv. We're gonna do another round, another set of the by parts. For u equals sine x, du is cosine x dx. The dv, which is e to the negative x dx, the v is negative e to the negative x. So for the integral of e to the negative x sine x, as another set of the integral u dv, we're going to use the same formula, but another set of the u b du dv. U in this case is sine x. The v is negative e to the negative x minus the integral, the v, which is negative e to the negative x, and du is cosine x dx. And then we write it to see negative e to the negative x cosine x. Two negative signs become plus sign e to the negative x sine x. We have 1, 2, 3, three negative signs. Now we have negative integral e to the negative x cosine x dx. It doesn't look like we get out of the integration, but the last integration here, it appears to look the same as the original problem, which we name is as a I. As a I. If we see from the top down process here, left hand side is I, I, which is original integration, and it appears another I on the other side, but with the opposite inside. So we add both sides by the same expression I. So we have 2I equals negative e to the negative x cosine x plus e to the negative x sine x. As we know, the I is the integral of e to the negative x cosine x dx multiplied by 2. So we divide all by 2. That gives us the result as 1/2 multiplied by negative e to the negative x cosine x plus e to the negative x sine x, and then plus c for the constant of integration. Recall here, the I is the integral e to the negative x cosine x dx. So twice of the I is the right-hand side. So divide all by 2 to get the result that we are looking for. And this situation is called repeated use of integration by parts. Let's see another example. Integral e to the negative 2x times sine of 3x dx. E to the negative 2x as an exponential function. LIATE as lead. E to the negative 2t, that's an exponential, and the sine of 3x as a trig function. So the trig function is a u, the e to the negative 2x dx as the dv. And this is again, we're going to name it as I of the integration, which is the bypass form or the integral of the u dv. Follow the formula u times v minus integral v du. So for the original terms, as u equals sine of 3x and the dv is e to the negative 2x dx. Now we're going to find the du. The du is 3 times cosine of 3x dx using the chain rule. And the v is the antiderivative of e to the negative 2x, which is e to the negative 2x divided by negative 2 or negative 1/2. Substitute in the bypass formula. The u is the sine of 3x and multiplied by the v, which is negative 1/2 e to the negative 2x minus the integral v, which is negative 1/2 e to the negative 2x du is 3 times cosine of 3x dx. We write it in the simplified form. We have negative 1/2 e to the negative 2x sine of 3x. 2 minus sine becomes plus sine, and the coefficient becomes 3/2 integral e to the negative 2x cosine of 3x dx. The second part here is in the integral of the exponential and the trig function. This part, we're going to repeat another bypass process. Same way to identify using the LIATE as e to the negative 2x as the exponential and cosine of 3x is the trig function. The trig function is the u, the exponential is the dv. So with this way, the u, which is the cosine of 3x, therefore the du is negative 3 sine of 3x dx. And the dv is e to the negative 2x dx. Therefore, the v, which is an integration of e to the negative 2x, gives us negative 1 over 2 e to the negative 2x. And then for the integration part here, use the bypass formula, which is u times v minus integral v du from the second set that we set on the side. So u times v, which is cosine 3x, times 1 over 2 e to the negative 2x minus the integral, the v, which is negative 1/2 e to the negative 2x multiplied by du, which is negative 3 sine of 3x dx. And the whole quantity here multiplied by 3 over 2 as a coefficient of the integration plus negative 1 over 2 e to the negative 2x sine of 3x. And then simplify by multiplying 3 over 2 to all terms in the parentheses in the back. 1/2 e to the negative 2x sine of 3x. 3/2 times negative 1/2 becomes negative 3 over 4 e to the negative 2x multiplied by cosine of 3x. And next part, we have 3 negative signs, so it can be negative, and the product of 3/2, 1/2, and 3 becomes 9 over 4. Integration of e to the negative 2x times sine of 3x with respect to x. And recall on the left hand side here, we use the notation I to represent the integral of e to the negative 2x sine 3x, which is the same as the last integral on the right hand side here. So we're gonna add 9 over 4i both sides of the equation. That becomes 13i over 4. On the left equals negative 1/2 e to the negative 2x sine of 3x minus 3 over 4 e to the negative 2x cosine of 3x. And just to remind you, what 13 over 4, the I is the integral e to the negative 2x sine of 3x dx. So our goal is to find out what is the integral e to the negative 2x sine of 3x dx. Therefore, we multiply both sides by 4 over 13. And then to get the integral of e to the negative 2x sine 3x dx as 4 over 13 of negative 1/2 e to the negative 2x times sine of 3x minus 3 over 4 e to the negative 2x times cosine of 3x plus c as a constant of integration.